Hello guys, welcome to our tutorial series. We are from Digitronix Nepal. So in this tutorial series we are going to create a custom IP of pulse modulation target for Zedboard. So we are going to use Zedboard IP integrator in this session. In previous session we already have unboxing session on Zedboard, and we have getting started session on Zedboard. So in this session we are going to create my custom like my PWM core. So you can also watch video tutorials on your YouTube channel, and you can also visit this website. So I would like to go to your IP integrator, so we can create a new project. We'll do next on this session. So we'll do my custom IP, and we're going to do next, and we will launch this. We'll do next. We're going to select the Verilog language, and we're going to do next and next, and in board section we're going to select the Zedboard. Okay, this will create the different project for Zedboard project, and we need to create a custom IP. So we are going to on the menu of tools there is a custom create and package IP option. So we will do next. We can create a new AXI peripherals. If we already have some projects we need to be packaged, so we can select that, but currently we don't have any projects, so we are going to create a new AXI 4 peripherals. These peripherals we work on AXI 4.0 bus protocols, which is a extension of AXI peripheral bus protocol. So we will change our IP name, PWM core, and you can also edit the description by Digitronix Nepal. And you can do next. So we are not going to change anything in this menu. We will place these default values, default options. So interface type, that light is good. There are two different other types like full AXI full mode, AXI streaming mode. So we are going to do light, means it will work as a slave light device, and data width will be as default. So we're going to do next, and in these options menus we are going to do edit IP, because we need to edit some Verilog sources so that our IP could be completed. So in this menu we will going to do click on edit IP. So we can do finish, and this will open the another Vivado IP integrated menu. So we are going to edit that sources on this menu. So here is some properties about our IP which we are going to make. So let's expand these sources. These default sources, which consist of S00AXI INST. This is the subsource of this project, and we need to edit both sources. So if we double click these sources, it will open on this menu. So we are going to change some source Verilog sources. So we have already written in our notepad++. We will just copy it. So initially we need to change this section, parameter section. We need to insert parameters on this section. So here is a parameter sections where we need to define the parameters. In second, we need to add the user ports, because we are going to need these ports: PWM0, PWM1, PWM2, PWM3. So in the port sections we are going to insert this program. This will add the ports, while previous insertion will be add an integer of 1024 bit, so 1024 value. So PWM counter max, which will be used on counter designing. So in the next session we need to modify the user logic. The following this is the user logic for pulse with modulation. Okay, let's go to Vivado, and in the section where Vivado have told about insert the user logic, we need to place that user logic program which defines defines the pulse with modulation, and okay, we're going to get that section soon. It must be at end of the session. So here is the section. So we are going to place this section without insertion code. So it will check the register value and perform the PWM operation, which we connected on LEDs. So this is good for the these as these AXI sources. We need to have some customization on Verilog code on that main sources. So we are going to save this. Here is also a clock. According to clock, we will check the values of PWM counter when clock, and this clock is 100 megahertz clock. So after 1024 values of PWM counter max, when it will become 0, then counter will be 0. So this counter will be increase, and it will be 0. So this will help on this conditional operation. So if the counter value is high, then this register's value will be high, and it will give the PWM 0 high. So in the next session we need to have some customization on next source. So this is also inserted on here. So in that section also we need to have define PWM counter max. So we just need to copy this section initially. So we are going to put that section on parameter section. Here is parameter section. So you can see that parameter section. We can also save the sources. We haven't saved it, so I will save it. Parameter section. In the next section we need to define a ports according to previous user. Sorry, we can just copy this section, port section. So it will define the 4 ports: PWM0, PWM1, PWM2, PWM3. Sorry, these ports is 0 to 3 ports, and we need to define this instantiation, which determines the port mapping. Actually, in BSDL we can understand about this section is a port mapping, but here we can see the instantiation of AXI peripheral bus. So we need to replace this instantiation section along with AXI buses, and we have inserted our PWM signals here. So we are going to replace this section. We can also add our section here. So we are going to paste this. So our ports are included in this section. So our ports will be mapped with the sub source of this. So we are going to save it. We can go to the package, IP my PWM port. So we can change the vendor name. This is the vendor name for us. Okay, and okay, go to the compatibility option of this IP packaging steps. So we're going to add one RTX 7 family, and we already have, I think, Zinc, so we don't need to add some Zinc family. So let's add this beta option. So after that we are going to change the customization parameters. In customization parameters we need to do merge changes for customized parameter. Without it will merge the parameters. So all the options are green ticked. So we also we need to have some changes on these parameters values. Let's change those. Okay guys, we already have this merge the customization parameters. So we need to go to customization GUI. We are not going to change any port and interfaces. We need to have output direction of those ports is PWM, and we are not going to change the addressing memory, and we are going to have some changes on PWM counter max. So in customization GUI, let's read the parameters of customization GUI. So we're going to click visible in customization GUI, and so specify the range. So we're going to give the range, means address range maximum of 65535, and we are going to do okay. Okay, okay, this value is good, 65535, so we are going to do okay. After this, okay, this will insert into page 0. So okay, this is on page 0 now. So we are going to do review and package. In this section we need to expand this section. Here is a package IP. We are going to do click on package. Okay, we are almost at the end of creating a custom IP, so we are going to do package IP. Let's package the IP. We are going to close this project, and we are going to do the integration part in another previous project, because this is the main IP editing window. So we are going to close this window, so it will close this, and this is our main PWM custom IP project. So we are going to create a block design. We can say system, we can say system, and we can do next. After this, our IP integration window will open. We are going to integrate our IP with Zinc core. So let's add previously a Zinc PS, Zinc processing system, and we will need our IP, but our IP need to be have added on our repository. So we are going to add first of all our IP we already have created in our repository, which can be added from project setting. Go to IP and repository manager, and I think our IP is been already added. This is our IP, my PWM core 1.0, so we don't need to add. If this is not appearing in your window, so you need to add from here. So you can locate where your IP is, because my IP situated area. So I located area, so I can select OK, select. This will appear, so apply and OK. So we will add our IP. That is name of my PWM core. So let's check our IP. So this is our IP. And another thing, we can see the tcl commands for this project. This tcl commands is very much optimized, so we can use these commands also instead of doing work on graphical user interface. While we are adding our IP from here, add IP, so we can just create a command, add a command like set property IP repo paths, and we can add some IP. And now we are going to do run block automation. This will add some interconnect block of AXI, because this Zinc PS works on AXI 3.0 protocol. However, we have make our slave device my PWM core in AXI 4. So this protocol need to be interconnected by a AXI interconnect. We can just click on run connects block automation, so it will add some. Actually we can do connection automation. You can do anyone previously, so there is no any rules. This will take some minutes of automation, because it will add some processing system reset, AXI interconnect for interconnection, and giving the reset signal. Okay, here is our interconnection block. Sorry, and we can do also run block automation. So just let's click run block automation, which will throw out the fixed IO and TTR ports into external. So we just did that job ourselves, because we can use control T, control plus T, like shortcut keys for making external of any ports on Vivado IP integrator. So these ports are provided to external. So after that we need to customize these ports, because our IP need to be customized. So in this customization window we are going to change. So in our custom IP, my PWM core, we already have prepared. So we need to set our pulse with modulation counter max into 1024. This is our counter value, so it will increase its value from 0 to 10024 with difference of 100 megahertz clock of Z. So Let's do okay. Okay, this basic integration has been almost completed, so we will do some. Okay, guys, we almost have completed the integration part, so we need to make this port. So we can just select these ports and we can click create port. Sorry, we need to do serially. So we can go to control key also is good. So I'm going to shortcut key and do the okay. I can even do control T, which makes that these ports external. Do the same process, but we are creating ports, so we can use control key, shortcut keys. So this is the block diagram, so we can regenerate even from TY commands like regenerate BD design. So it will sorry. Okay, just we can create these commands, that is regenerate BD layout. So I have to have BD design. So after that we need to have validation, which will check the interconnection between these IPs, because we have just created one IP of this my IP code. Other 3 blocks are from Vivado IP integrator. We are going to create this IP. Xilinx has already provided this IP in IP catalog. So we have go to sources. So let's create a SDL wrapper of this IP integration. So let Vivado manage this part, and this will generate SDL. After that generation successful, we need to put some constraint on this section. Okay, we need to add constraint, so we can even add sources, create a constraint, and we going to add files. We also can have like, okay, this is the main process. I just want to add copy of sources, so add files. I have my constraint. We can go to computer. I will look at my constraint. I have a different location. Zedboard XY Zedboard masters. This is the main constraint. Okay, we can click Zedboard master and we'll click on copy constant files into project. Finish. It will create a constant. We need to uncomment the main section of LEDs. So it is LEDs. Actually, I have made a mistake. This is a function of size, so I will remove this. I will add again. Sorry for that. I already have located, so I will go to Zedboard master. Sorry, I need to add this section. This is okay. So and let's add some section. What is LED? We need to go to bank, not bank. Okay, this is the user LEDs, and we will change user LED section by this our custom. We just need force. Save it. In another section of standard CMOS, we are good on customizing our constants, so we will just go to do not synthesize the constant because we don't need to synthesize this, and we will go to run synthesis. So save it. It will take some time because we want to take time for processing, so it will take I think 2 to 5 minutes on synthesis, and then after that we will go to implementation. We already have a constant sources on this, so after that we will select bit stream, and then we will export our hardware including bit stream and launch the SDK. This is the main process. So so let's wait for some time. Let's wait. Okay guys, my implementation is also been successful, so I will go to the generation of bit stream. It will do I think faster than previous steps implementation. So after bit stream generation completes, we'll go to file and go to export the hardware. So let's wait some time. This is also creating a typical script of this project sources. So it will complete soon. We can see the updates of resources, what is happening on here at log. So we can also see the corresponding typical scripts in table console. So we can use these scripts for creating projects and doing this operation. And I have lots of critical warnings. Let's check these critical warnings. What it takes about. Okay. I have used the Zedboard master XTC constant set. I have just replaced some only because I don't need most of them. So we can see the constant. So I just need these sections only. Other sections will unused in this section because program hasn't included any port declaration of other sections. So it is also successful. So we are going to do create export hardware and include bit stream. We're going to do okay. It has been done. Then we will launch the SDK from local project directory. So let's wait some time for launching the SDK. Okay, it will execute soon in my computer. So we already have 23rd minute of this video. We need to have some time for launching this SDK. So see this. Let's see this SDK panel. So we are going to do new project application type of project. So it is still importing hardware specification. We already have exported in Vivado API. So let's wait. Okay, this SDK has called the included the so sources we have exported in this session. So we will okay, let's keep the project name, application project name for this SDK, because SDK actually programs the processor, because it creates a programmable file processor, which also includes the bit stream for programmable logic. So in our Xilinx 7000 series, there are two cores. One is processing system and another is programmable logic. Processing system consists of dual core ARM Cortex A9 processor, which is from ARM. Actually ARM licensed these cores to Xilinx, so Xilinx include these cores, PS cores, in Xilinx 7000 chip, which is also included in Zedboard. We are going to implement our project in Zedboard. And in PL means programmable logic section, it consists of 7 series of FPGA main core, which is also similar in other like Cortex 7, Kintex 7 family, because the FPGA core is similar, but they have more density of logic cores than Xilinx family. So let's do next and create a empty application, blank project. So let's click is it will create a application project, and we are going to add a source on C programming language for instructing the processor what it need to do when the PWM 0, 1, 2, 3 is activated. So in our PWM custom IP source we can add, sorry, we can add new file we can add new file. The file a file name will main.c. This is the main program. For ARM Cortex N9, so it will add to the current project setting. Okay, our main processor program processors.c has been opened. We have also included program for processor in this C syntax. So here is a header file for parameters and IO. So here is a addresses for pulse with modulation, our IP. This address has been updated from our VIVADO project exports. So in our main function here is non-zero, we have one another variable I, while one this is a continuous infinite loop. So if number value is equals to 10, 0, 2, 4, which is a counter value, then num will be 0, else num will be plus plus. And in else condition means if the num is not haven't reached 10, 0, 2, 4, then it will also keep the output of my PWM value of NOM. NOM is increased, so it will give the value of 0, 1, 0, 1, 0, 1, and with increase of delay this will be activated. And there is also for loop. So we will copy these sections to our SDK panel. So let's paste it and let's save it. After this we are almost at the end. We need to go to Xilinx tools. We have to connect our FPGA, but we haven't connected yet. We will check this. Okay guys, we already have inserted our main code for processor in main program processors. After this we will program our FPGA. Actually my this UR connection has not been recognized previously, so I have installed the this Cypress driver installer, which can be get at Zedboard.org, or you can use this type of documentation for installing or updating this Cypress driver for recognition. So my device is in COM port 7, so I will go to Xilinx and program FPGA. This will program FPGA, so it will send the PT stream. Okay, sorry for that. I have some issues still on this FPGA, so I will fix it. And then after that programming has been completed, then I will run. After that PT stream program, I will run is the launch on hardware. This is main process for programming the Zedboard. So thank you for watching. I will test my Zedboard ultimately, so you should test yourself. So thanks for watching.